Thank you, Arab University, especially Dr. Irfan Yusuf Saab and Dr. Zaib for giving me this opportunity. Basically, this presentation is based on my practical experiences and how we control E. coli in different poultry practices at breeder farms and broiler farms. I will go through very shortly because I am saying that I have only 20 minutes. So there are some things that should I skip, like Escherichia coli. Everyone knows what is this bacteria, and it's belong to family Enterobacteriaceae, and it is basically non-spore farming, acid fast, and easily killed by you can say disinfectants, and it have different antigenic structures. These antigenic structures are basically for the serotyping of this bacteria. And if we classify it on the basis of tropism, we are talking about avian pathogenic E. coli. Other E. coli are also very much important, but the yellow one is avian pathogenic E. coli. We will discuss about that. First is the transmission. Now it is established fact that E. coli is vertically transmitted. E. coli is vertically transmitted when the infection goes in ovaries, and also a transvariant transmission is also established. E. coli vertical transmission can also be verified when we see the when we see the resistant genes are transmitted from breeder flocks to the broiler flocks. Horizontal transmission is also important because only 5% you can say vertical transmission is done, and other 95% is transmission is mostly in hatcheries. And other way of transmission is ascending transmission. When there is the colica infected with E. coli, it ascends to the you can say oviduct, and mostly it infects the breeders. And we have also great economic losses in the birds that are more than 40 and 45 weeks due to that ascending infection. This is basically, you can say, different kind of models that are now discussed for the transmission of E. coli. In this, we can also see the respiratory system and reproductive system and also the digestive system all are involved, and it is vertically transmitted to the next progenitors. So E. coli is causing huge economic losses all over the world, and if we and it also causes the you can say co-infections. And if we talk about the co-infections, the economic losses are much more higher than we discuss in this slide. So this is our data. Basically, E. coli prevalence is increasing day by day. These are other important research institutes. Basically, our laboratory is the provincial reference laboratory. We have information and get reports of all the diseases. And from among the bacterial diseases, E. coli is, you can say, most prevalent organism among all bacterial organisms. So it causes omphilitis, swollen head syndrome, salpingitis, pericarditis, perihepatitis, panophthalmitis, and also nowadays when there is you can say less humidity, like March, April, and May, we also have respiratory infections in which we see the plug formation, like we see here in this slide. This is also due to E. coli. Ehrlichitis, arthritis, and polygranuloma. These all infections are done from E. coli. So we have always face a problem of respiratory plug formation when there is less humidity. Most of these infections are caused by E. coli, and we studied more than 100 cases, and we see that in these cases, 98% we isolated E. coli, and 19% we isolated Mg, and 94% involvement of H9N2, and we have also detection of 24% of IB. But among all these, E. coli was the most prevalent organism in these kind of the cases. So if we have the prevalence and studies on E. coli, there is a study in which a scientist took 320 samples, and he noticed that 50% sample was positive for E. coli and 45% was positive for ESBL E. coli. And in our studies, we have, you can say, do the antimicrobial resistant and antimicrobial sensitivity of most of the samples that are taken to the our laboratory. Basically, our laboratory is also the provincial reference laboratory for antimicrobial resistance from the Fleming Institute. We are doing a coordinated project with Fleming Institute, in which in this you can see that the different kind of antibiotics like ampicillin, tetracycline, they are resistant, and some antibiotics like injectable antibiotics, gentamicin, and some new antibiotics, phosphomycin, they are sensitive, and most of other are now resistant. So what are the causes? As most our previous colleague, he very elaborately narrated the antimicrobial resistance. So this is the one of the cause. Second is managemental suppressive. Third one is intensive farming into fast growth and high production. Fourth one is concurrent and immunosuppressive and subclinical diseases. And fifth, in my opinion, is improper diagnosis and treatment. So we discuss antimicrobial resistance as already our colleague has mentioned it, but for the E. coli, it's very much important because it has very short generation time, almost 20 minutes, and it can spread antimicrobial resistance faster than any other organism. So, how can the drug resistance is improving? Exposure to suboptimal level of antimicrobials and exposure to microbial carrying resistant genes. In appropriate drug lack, in this we can say the lack of quality control in manufacturing because there is a report that some antibiotics that are available in markets are not according to this proper standards. Unethical use of ATPs, like from the government of Punjab, they have listed, you can say ATPs which can be used in feed, and if someone use more than that or any other thing that is not, you can say, provided in the law, so unethical use of ATPs in the feed is also a problem. Excessive prescription of antibiotics without proper diagnosis, because our veterinarians mostly doesn't, you can say, rely on diagnosis, but only prescribe huge number of antibiotics. This is also one kind of reason. Wrong combination, like already my colleague said that there are different kind of combination are prescribed in the field. Don't have a synergism or any kind of importance. Second, in my opinion, is management suppressive. Like we want to have very high production in very less time. So for that, there are some improper disinfection in the houses, temperature fluctuation, humidity fluctuation, we will discuss in detail, and congestion suppressive. Third one is intensive farming with fast growth and high production. Now, the brothers, breeders, and layers, you can say, are very genetically, you can say, genetically enhanced organisms, and they require, you can say, very high level of housing and other things, and we are providing less plot time to have maximum, you can say, progeny and increase stock density to have maximum, you can say, production. High growth required more sanitation, and if we don't have good quality of farm management, we will have increased success. And like we are going toward artificial insemination in filter box, and by artificial insemination, there is a chance of increase E. coli you can in the protein.
So the other diseases like concurrent diseases in the crop is mostly for MG, Salmonella, and other diseases. It may cause increase, you can say, problems of E. coli, immunosuppressive diseases, subclinical diseases. These can also increase the prevalence of E. coli. Improper diagnosis and treatment, excessive use of antibiotic without diagnostic and sensitivity. And we also have defective antibiotic sensitivity assays, like in some of our laboratories are doing sensitivity, but these are without proper recommended guidelines and using of wrong combinations. So what are the solutions? In my opinion, and what we are doing with our farmers that are consulting with us, these are the fourth antimicrobial resistance solution. Use antibiotic as the last option. Improve management of reflux and start with alternative of antibiotics. There are many alternative antibiotics we will discuss in detail after this slide. And vaccination. Vaccination is also an option and it is practiced by some companies and in breeders and you can say in the grandparent flock it have some good results. But if we have to use antibiotics, it should be the last option. Use proper dosage according to minimum inhibiting concentration. Use proper quality of antibiotics. We should have knowledge. These companies are using good quality of antibiotics and don't underdose and don't use medicine for a short time. Give proper time to perform the medicine and take proper guidance from research institutes. Like this is not about the E. coli, but we have a study on mycoplasma, and we see that the minimum inhibitory concentration of mycoplasma is much more higher than the total mycoplasma minimum inhibitory concentration in the literature. Due to that, we are also working on E. coli salmonella minimum inhibitory concentration because of the resistance we have. You can say our organisms mostly don't respond on the reported literature. So we have to work hard on that. So alternative antibiotics, we have many classes: probiotics, prebiotics, symbiotics, phytobiotics, and many companies are already using these kind of products, fatty acids, bacteriophages, and different miscellaneous other things. These are in practice. We should use regularly these alternatives to avoid the use of antimicrobials. Vaccination is the also solution of second option of alternative of antibiotics. We have different kind of vaccine available, live vaccines and field vaccines. Live vaccines have their own limitations, field vaccines have their own limitations. Like if we use live vaccines and our flocks is Salmonella mycoplasma positive, we may not use antibiotic in early gene so that can cause some problems. And killed vaccines have some you can say other limitations, like they are mostly effective only for serotype specific. And some countries are also using homologous vaccine or autogenous vaccine for E. coli. They isolate the E. coli from that flock and grow it into the laboratory and make field vaccines and use them for serotype specific vaccine. And this is also a very good practice. But these all things are under research and in progress, also in international countries, also in Pakistan. So how can we overcome the management stresses? First one is disinfection, and mostly E. coli is used as an indicator organism. If a house has E. coli and we isolate E. coli from after disinfection, it means that the house is not clean. So terminal disinfection is very much important. Proper control of temperature, mostly. The temperature is very much important for as you know, the temperature is high in brooding and after that the temperature is lower. So if you don't provide the proper temperature, it will cause stress and we have more E. coli problems. And humidity is also very much important. Like most of the farmers knows about the temperature, they have temperature meter at farm, but they don't take very much care of the humidity. important. So the 55 to 65% humidity is very much important. And nowadays, in arid area, I think the humidity is only 25 to 30%. So we have humidifier and other things to take care of these problems. Increase space according to the time. Intensive farming and fast growth, we can have improved facility to that can match with the improved genetics, and we should observe proper rest time. And most of the companies are placing 7 flock in a year. I think to avoid the very fast growth, we may place 6 flocks in a year of color. So observing proper rest time, we may reduce the E. coli and other infections also. Proper facilities according to recommended stock density. And when there was an inception of control farming plot in Pakistan, we were giving only 0.6 feed to the brothers. Now, most of the companies are giving 0.7 and 0.8 due to very high disease they face. So we have to give the proper stock density. Good quality of water is very much important. Like the water should be have very good pH and very optimum TDS, and it should be and there is a proper list and which bacteria and which minerals water should have, and good quality of feed. And if we have to use artificial insemination, so we should do it in cage systems or in clean environment and with quality of semen extender, because during AI, artificial insemination, we have the semen may contaminated with feces and fecal material, and we may have increased infection. So sanitation and clean practices at breeder farm and hatcheries and also at the chick transportation should be, and most of the chick transportation in Pakistan is on, you can say, all type of vehicles. So we should have a proper vehicles for the transportation of chick to avoid early chick mortality and to have maximum production at first feed. So other diseases like the chain flock that are that you can say certify you that these are vertically transmitted feed flocks, and vaccinate properly against immunosuppressive diseases. Subclinical diseases like coccidiosis and tritis should be treated at proper time. And health monitoring of the flock is very much important. And after health monitoring, we should have proper veterinarian that may formulate your health monitoring plans. So, in proper diagnosis, use laboratories for the preventive medication. If you have any problem, go to laboratory, have isolation of the bacteria, and have antibiotic sensitivity, and use antibiotic. After that, you can say time, and use standard method of sensitivity. Like most of the farmer needs results within 24 hours. That is not practically possible, and that is not practically according to proper CLSI method. So use proper interpretation of, and there are some other problems like if a farmer has sensitivity of neomycin, and the neomycin doesn't absorb from the intestine, and so it cannot be prescribed. So proper veterinarian should have proper interpretation of lab reports also to have maximum output from the reports. Use proper dosage according to the body weight and MICs. So this is at the last. Controlling avian pathogenic E. coli requires a multi-phasic approach, prioritizing strict biosecurity as already mentioned, and monitoring antimicrobial resistance due to diverse mixed of avian pathogenic strains, effective vaccinations and effective vaccine. You can say it's a continuous process, and having alternative antibiotics, and their use is also continuous process, and we have to coordinate with the academia and with the research institute to reduce this problem. Thank you.